On March 10, 2016, two opponents sat across from each other in a quiet room in Seoul, South Korea. On one side was Lee Sedol, a national hero and one of the greatest Go players in history. Sitting across from him was AlphaGo, a computer program developed by Google's DeepMind. Experts had long believed a machine beating a human master at Go was decades away. The possible board configurations exceed the number of atoms in the observable universe, a complexity that made the game feel uniquely human. But midway through the second match, AlphaGo placed a stone on the board in a way that confused every professional commentator watching. Move 37 was a move that no top human player had ever considered in 2,000 years of study. Lee Sedol was so stunned he left the room for 15 minutes just to catch his breath. While observers in the West viewed this as a clever algorithm winning a game, the Chinese government treated it as a direct challenge to their technological sovereignty. Within a year, they released a national strategy declaring AI a top priority, with a mandate to lead the world in the field by 2030. AlphaGo's victory started a technological Cold War, forcing a top-down mobilization that would change how China approached innovation. To enter this race, you need a physical engine. Specifically, you need graphics processing units, or GPUs. These are tiny pieces of silicon packed with tens of billions of microscopic electrical switches. The global supply for these chips is a strict monopoly. The American firm Nvidia designs the architecture, and a single company in Taiwan, TSMC, manufactures nearly 90% of the world's most advanced AI processors. In response to China's AI ambitions, the United States imposed severe export bans. These rules legally blocked China from using TSMC's manufacturing plants and prevented them from buying Nvidia's top-tier GPUs. Many Western experts assumed this was the end of the story. Because China was locked out of the hardware supply chain, their goals were presumed to be dead in the water. But today, Chinese AI models like DeepSeek and SeeDance are going viral, matching the performance of the very American tools that were supposed to be out of their reach. Since they couldn't buy the best hardware, they focused on making the chips they did have perform in ways they were never designed for. To understand how they bypassed the ban, look at the AI stack's 3 layers: hardware at the bottom, model in the middle, and data at the top. Because hardware was walled off, Chinese engineers directed their energy into optimizing the middle layer, the model. Operating in a state of hardware starvation, companies like DeepSeek were forced to build their AI using older, stockpiled chips. To stay competitive, they had to become obsessed with computational efficiency. Their first breakthrough was pushing a design called Mixture of Experts to the limit. Instead of lighting up the entire brain for every query, DeepSeek divided the model into 256 tiny experts. When you ask it a math problem, only specific math nodes wake up, allowing the rest of the system to stay dormant and save power. They also invented a memory compression tool that shrinks the AI's short-term memory footprint by 90%. This allows the model to maintain the context of a conversation while using a fraction of the usual computing power. Finally, they shifted to pure reinforcement learning, letting the AI mathematically grade its own logic over and over again, rather than paying thousands of humans to manually tutor it. DeepSeek proved that the brute force method of throwing billions of dollars and endless chips at a problem is not the only way to build a genius-level engine. But solving the math is only half the battle. The AI race is now moving to the top of the stack, the data layer. This is the fuel for the brain, and it is where Western tech giants are beginning to hit a wall. American companies trained their early models by scraping the public internet, but to teach an AI how the physical world works, they need multimodal data, high-definition video and audio. In the West, high-quality, legally accessible video data is becoming increasingly scarce. China, however, has built an ecosystem of closed-loop super apps that natively generate massive, categorized databases every day. ByteDance, the parent company of Douyin, doesn't need to scrape the public web. They host billions of video files directly on their own servers, uploaded by hundreds of millions of daily users. Their AI generator, SeeDance 2.0, trains on this proprietary metadata. It knows the exact camera angles, the lighting conditions, and when a viewer loses interest. This native pipeline allows the AI to generate physics and audio synchronization that Western tools are struggling to match. In this stage of the race, hardware dominance is no longer a guaranteed win. The advantage is shifting to whoever controls the deepest reservoir of real human behavior. We are seeing two strategies diverge. The American approach relies on immense capital and hardware spending. The Chinese approach relies on microscopic algorithmic efficiency and internal data loops. While the US is defending the hardware at the bottom of the stack, China is focusing its efforts on conquering the top two layers. China does face a potential obstacle. To make their models understand Western culture or cityscapes, they will eventually need data from outside their own borders, making a collision over global data access likely. The narrative of a simple chip war is becoming a thing of the past. The battlefield has already moved to the hunt for untapped, real-world human data. Move 37 did more than defeat a grandmaster. It forced a rival power to find a new path around a blockade, changing the trajectory of artificial intelligence.